Okay, grade 8, here is your Formative Friday on a Monday, the answer key. So all the mistakes you made, just try to watch the video for the ones you got wrong. Try and make the necessary corrections, and hopefully next Formative Friday you won't make those same mistakes again. So the first question is written out half of 5/8. So really, half of is really dividing by 2. So you could think of this question as being taking 5/8 and dividing it by 2. And when you think back to fractions and you think back to the unit when we divided by whole numbers, you learn to keep the first fraction, change division to multiplication, and use the reciprocal of 2. And since 2 is 2 over 1, the reciprocal of 2 is 1/2. I remember why we do this. We do this because it gives us the same answer of dividing in half. The product of these two fractions will be the same answer. So multiply your numerators, multiply your denominators, you get 5/16. The other way you could have done it is simply to have interpreted the question properly. And if you have half of 5/8, half of, we've learned, was multiplication, 5/8, and you have the exact same question you just had before, and your answer is still 5/16. So if you have half of 5/8, so if I was to draw eighths, all right, there's our eighths. Take my green pen. This is 1/8, 2/8, 3/8, 4/8, 5/8. So I have 5/8 of a pizza. If I get to have half of it, I'm going to cut each of these into half, as well as the ones that I don't have. And I'm going to shade in black. That's half of this piece. That's half of this piece. That's half of that piece. That's half of that piece. And that's half of that piece. So if I'm getting half of 5/8 of a pizza, I'm really getting 1, 2, 3, 4, 5 parts. And since I cut everything into half, there's now 16. So we get 5 parts out of 16. That's just a review of how to divide fractions by a whole number. The second question was a division of a mixed fraction by a fraction. This is actually an easier question. And the easiest way to approach this question was to change the mixed fraction to improper. So this question here would be the same thing. And just like the last question, keep your first fraction, multiply by the reciprocal. It's one method we learned to get the same answer. So for some people, they would have multiplied the numerators and got 28, and multiplied the denominators and got 12. And then they would have said there's 2 12s and 20, that's 24, plus 4 twelfths. And they would have said that's 2 1/3 as an answer, because you'd reduce that fraction. But some other people realized that when multiplying fractions, there's cross reduction, and you could have cross reduced 4 over 4, and you would have got 7 over 3, which is 2 1/3. Same answer, different way to do it using cross reduction, because here I had to reduce here. So this, what happened right here, actually went on right here before I did my lowest terms. Question 3 is an order of operations question with fractions. And again, we have 5 1/6 take away. And since we're doing order of operations, your product must be done first. So I'm just going to write down this first. I know it's going to be 5 1/6 take away whatever the product is of those two. So 1/3 multiply by 5 halves. I'm going to change 2 1/2 to improper. I'm going to multiply the numerators, multiply the denominators. I get 5/6. So I'm going to put 5/6 right here. So instead of being 5/6, 5 1/6 take away the product of 1/3 and 2 1/2, I can say 5 1/6 take away 5/6, because 5/6 is the answer to that product. If you wanted to, you could use, you could keep the whole numbers the way they are. I like changing it right away. So 31/6 take away 5/6, it is 26/6, which is 4 2/6, I think. Is that right? Yeah. Which is 4 1/3. So the answer for this question is also 4 1/3. Okay, next question is an integer question with bed mass. So we have how many operations? Well, right here we have multiplication. Right here we have subtraction with brackets. So we have subtraction with brackets. There's addition and there's division. So there's 4 operations. The first thing we're going to do according to the bed mass is our brackets. Now this is a bracket because there's something to do in here. This is not a bracket, right? That is just separating the integer sign from your operation sign. So it doesn't really count as a bracket. This is really what a bracket is because there's something to be done inside. So -5 multiplied by whatever 12 take away 14 is. And 12 take away 14, some people think it's 2, but it's actually -2. So when I simplify my first step, my first of my 4 operations, I get that. The next thing I'm going to do is my division multiplication because there are no exponents. Now remember, division and multiplication is one step in order from left to right, from left to right. So it doesn't matter if it's division first and multiplication. It's as you read it from left to right, what is the first thing in division multiplication you see? And the first thing I see is that one. So -5 times -2 is 10. Sorry, divided by. And the next thing I see is right here. So 10 plus, what is 10 divided by 5? It's 2. And a positive divided by a negative is a negative. So I'm going to put that in brackets. And the final step is simply to add them together, addition, subtraction. 10 plus -2 is 8. Question 5 is also in order of operations. It's actually easier than question 4. You have multiplication, multiplication, subtraction, multiplication. So you have 4 operations again. I'm just going to do my multiplications here. So 10 times -2 is -20. -20 times -5 is 100. And the last thing is 100 take away whatever these two numbers multiplied are. So 5 times -1 is -5. So I really have 100 take away. Instead of saying 5 times -1, I can say 100 take away -5. And the easiest way for us to subtract integers is to keep the first integer, change it to addition, and use the opposite, and you get 105. Right? Or if you just had this question, you want to think of it contextually. I have $100. My grandmother takes away $5 worth of debt. Well, if she takes away debt and I don't actually owe anything, it's like a credit. So I'd have 105. Right? Either way you want to think of it, it's still 105 is your answer. Question 6 is the volume of a cylinder with a radius of 5 centimeters. So the first thing you probably should have done is drawn it. Draw your radius of 5 and draw your height of 10. Now its volume, and since we spent a whole chapter on it, the volume formula is the area of the base multiplied by the height of the prism. So the area of the base, well, it's a circle base. So for that area, we need to use pi r squared multiplied by the height of the prism. It says use 3 as pi. So 3 multiplied by the radius, which is 5, squared, multiplied by the height, which is 10. And going back to that last question on order of operations, we have e here. So our exponent is done first. So 3 multiplied by 5 squared, which is not 10, it's 25. That gives us 75 times 10, which is 750. Now remember, we're dealing with centimeters. So it's volume, so it's 750 cubic centimeters. And we know that 1 cubic centimeter is equal to 1 milliliter of water. So if this was a can, it would be able to hold 750 cubic centimeters or 750 milliliters of liquid. Question 7 says the surface area of a rectangular prism. So there's our drawing of our rectangular prism. We have 10, we have 12, and we have 5. It really doesn't matter where you put them because it doesn't say length, width, and height. I'm just going to put it like this. So for some of us, or for most of us, you probably drew a net because you wanted to visually think about what are all these faces looking like here. And when you drew your net, I'm going to put in bottom here and top up here. This will be my front. This will be my back. This will be my left. And this will be my right. So if you think about the front, this is the front face right here. Right? And for dimensions, it's 10 this way, and 5 centimeters this way. So the front is 10 by 5, which is 50 square centimeters. And since the front and the back are identical, I can put a 50 centimeters in that back one as well. On my right, it is 12 by 5, so its area is 12 times 5. which is 60. And the left is also 60 because it's an identical face. And my bottom, which I can't, well, I can do up here, I guess. My top and my bottom. My top is 10 by 12. So the top is 120 and the bottom is 120. And when you add those up, you get 240, 340, 440. And you get 460 square centimeters of total surface that make up all 6 faces of that rectangular prism. And notice it's square centimeters for area. If you go back to that last question, it was cubic centimeters for volume. Okay. Question 8 says a cheetah can run 200 meters in 10 seconds. So this is from our ratio and rate. So it's 200 meters in 10 seconds. So we're going to do distance over time. And we want to ultimately get it down to 1 hour, right? We want to know how many kilometers per hour, right? How many kilometers per hour. So the first thing a lot of people did is they probably went down to 1 second. But I wouldn't have done that. You could have, but you don't have to. And the reason why you don't is because if I think of 10 seconds, 10 seconds times 6, and times 6 is going to create a proportional rate, a proportional unit rate, and this time 10 times 6 is 60 seconds, or 1 minute. So we have another unit rate, which is 1,200 meters in a minute. And again, if I want to make a new one out of 1 hour, how many minutes an hour? There's 60, so I'm going to multiply this by 60. That's 72,000 meters in 1 hour. That's how fast a cheetah could run if it's at that rate of speed indefinitely. And there are 1,000 meters in a kilometer, so 72,000 meters would be 72 kilometers. So the answer for this one is 72 kilometers per hour would be its speed. Question 9 says, if a large coffee costs $3.20 for 500 mils and a small costs $2 for 250, which is the better deal per 100 milliliters, and how much do you save per 100 milliliters? So per 100 milliliters means my volume is going to be my bottom term. $3.20 for 500 mils. Like we want to get it down to 100 mils. So for this one, I don't need to get it per 1 mil. Some of you are going to 1 milliliter, which you don't have to, but you could if you wanted to. I know that if I divide 500 by 5, I get this unit rate that I want per 100 mils right away. $3.20 divided by 5 is 64 cents. So that large coffee is going to cost you 64 cents for every 100 milliliters of coffee you drink. That's its unit rate. And remember that 100 mils, the reason why it's a unit rate is because that's 1 deciliter, right? 1 deciliter is 100 milliliters. That's its unit rate. The second coffee is $2 for 250. Now, again, if you went down to 1, you could. You don't have to go to 1, because I know that 250 divided by 2.5 is 100, and $2 divided by 2.5 is 80 cents. So the cost of the small is 80 cents per 100 mils. So the question you had to answer is, how much do you save per 100 mils? If this is the cost for the small and this is the cost for the large, if you subtract those two, you save 16 cents per 100 milliliters if you buy a large coffee. And that's the answer we were looking for, 16 cents per 100 mils. Question 10 says a right triangle has legs that measure 10 and 12. So legs mean these two sides, because this is called the hypotenuse. So legs that measure 10 and 12, what is the length of the hypotenuse to the nearest tenth of a unit, meter? Well, two ways you could do it. The one we were most familiar with is actually drawing the squares onto the legs of the hypotenuse. Because Pythagoras said the area of the squares attached to the legs of a right triangle equal the area of the square attached to the hypotenuse. This area would be 100. This area would be 144, which means the area of this square would be 244 square meters. The square root of 244 would be its side length. So therefore, the square root of 244 is roughly 15 decimal 6, I think. 15 decimal 6. Take my calculator. Square root of 244 15.62, yeah, 15.6. So the length of the hypotenuse to the nearest tenth is approximately 15.6. In question 11, it says, what's the area of this triangle? And this is a little tricky because what I didn't give you was the length of the base. So it's actually a two-part question. In order to get area, you need to have base times height divided by 2. The base you don't know, but the height you do know. Right? So I have to figure out how long is that base. So because it's a right triangle, we know we could use Pythagoras again. This is 144. I don't know this one, and I know this is 400. So 144 plus what is 400? Well, if you subtract to figure it out, this one must have been 256 as an area. And if the area was 256, its side length had to be the square root of that, which is 16. So now I know my base. So 16 times 12 divided by 2. 16 times 12 is 192 divided by 2, which is 96, no, 96? Did I do something wrong here? Meters squared is the area. I think it's 96. Maybe. I better do a calculator. 16 times 12 divided by 2. Yeah, it is. 96. Okay. So the area of this triangle is 96 square meters. Question 12 says, what is the coefficient in the equation that matches this graph? Well, you have 3 points here. So when finding an equation from a graph, you're going to need a table of values. So the first thing I'm going to do is make my table of values. And I'm going to plot those 3 points that I know. So I know x is 0, x is 1, and x is 2. So 0, 1, and 2. I know the values if I go down for them, right? So when x is 0, y is negative 2. When x is 1, right here, y is negative 4. And when x is 2, y is negative 6. Now what we've learned is to find the equation that matches the table of values, we need to find the difference here divided by the difference here. Well, the difference between negative 2 and negative 4 is not 2. It's actually negative 2. And the difference here is 1. So in our equation that shows the relationship between x and y, the coefficient we'll use is negative 2. Even though it doesn't ask for it, I'm going to take that first pair, substitute that in, even though we know that when it is 0, the y value is the constant. 0 does not equal negative 2. But if I put a minus 2 here, it keeps them equal. So even if you didn't know if coefficient was this one or coefficient was this one, you probably could put negative 2 in the remote and still get it right. So even if you misinterpreted this word and thought it was constant, you still put the correct answer in the remote because negative 2 is the constant and coefficient. Question 13 is an algebra question using distributive property. So because we have not one group of these, but I have negative 2 groups of these, I have to isolate doing one of two things. I can use expansion, which is this method here, or I can use division first. So for this one, I'm going to do both. I'm going to do division first, and I'm going to do expansion to show you that they're the same answer. So with expansion, I have negative 2 times x. So instead of having 1x, I have negative 2x's. I have negative 2 times negative 10, which is actually a positive 20. So when I expand, that's the equivalent expression or equation to that. Now I just have an easy two-step equation. Get rid of my constant. Divide both sides by negative 2. X equals. So since 32 divided by 2 is 16, and a negative divided by a negative is a positive, the value of x has to be 16. And if I go back up here and substitute that in, so instead of saying x, I'm going to take my eraser and erase it. Oh, hang on a second. I'm going to erase that x. And instead of x, I'm going to put in my value of 16 and see if these two sides are the same. So negative 2 multiplied by, well, 16 take away 10 is 6, and negative 2 times 6 is negative 12. So the value of x does have to be 16 to make them work. Now over here on this side, if you wanted to divide both sides by negative 2 first, which we learned is appropriate, instead of having negative 2 groups of it, I have one group of it. And negative 12 divided by negative 2 is 6. One-step equation, add 10 to both sides. X still equals 16. It's just a different way to get the answer. Question 14, you have a two-step algebraic equation. The difference with this one is this is your constant. And your coefficient is really, believe it or not, all three of these are the same thing. So really you have a fractional coefficient for your x, right? But the first thing I'm going to get rid of is my negative 10, because you get rid of your constant first to make it easy. So by adding 10 to both sides, I get a fifth of x is equal to 11. And a fifth of x, if I was to think about what that looks like, that's a fifth of x. If I multiply it by 5, if I multiply a fifth of x by 5, I actually would have a full x. So if you multiply both sides by 5, you get x on this side, and over here you get 55. And again, if I was to erase this x, oh, sorry, that's not what I want to do. If you were to erase this x and put 55 in again, negative 10 plus 11, 55 divided by 5 is 11, is 1, so it does work out. Question 15, you have your equation set up backwards where your constant is over here. So you're going to add 2 to both sides to get rid of it. 14 equals negative 4x. Divide by negative 4. Now right here, if you jump to your calculator, just wait a second because I want to think of it as an improper fraction. 14 quarters. If you want to think of it instead of division, think of it as an improper fraction. That's 3 2/4, or 3 1/2. So it's a positive divided by a negative, so your answer is x equals negative 3 1/2. Right? And I can think of that without using actual division. If you don't believe me, take your calculator. 14 divided by 4 is 3.5. Question 16, what's the probability of flipping a heads twice and rolling a 6 on a normal dice? The grade 8 outcome is to take the first event, which is heads, write it as a fraction. The second probability, flipping a heads again, is 1 out of 2, and a 6 would be 1 out of 6. The product of all of those is 1 out of 24. 1 divided by 24 is 0.0416, which as a percentage is approximately 4%, or 4.1 or 4.2%. But since it's the nearest percent, 4 is all we needed.